Okay, for our next example of considering the domain of a function, our function this time says f of x is equal to 1 over x minus 3. So now we're dealing with a different type of function. It's not a linear function. This is actually a rational function because it is in the form of a fraction. It's a rational function. So we have to recall back to elementary school. What type of fractions were there that made no sense to us when we were in elementary school? And it was precisely those fractions that actually had 0 as the denominator. There's no such thing as being able to divide something by nothing. You can't divide by 0. But on the other hand, we can have 0 in the numerator, and we know that our answer here is 5. So when we consider rational functions, when we consider the domain values, we have to consider all of those values that will not produce 0 in the denominator. So since we want the domain for this rational function, what we do is we're not considered with the numerator unless there's some other type of function in the numerator, which we're going to consider later. So what we do is, in order to find out the domain, we first go in search and say, okay, where is my denominator equal to 0? Where is my denominator equal to 0? So I take my expression for my denominator, which is x minus 3, and I want to know for what values of x will this thing be equal to 0. And everywhere else is fine. So we know this is an easy one-step equation. This says that x is equal to 3. So the only number, the only real number that will produce 0 in the denominator is the value 3, because 3 minus 3 is 0. So the domain will be every real number except 3. So if you want to write this in integral notation, you can say domain is equal or is from negative infinity all the way up to 3, union pick back up with 3 to positive infinity. And notice how we're not including 3 in our solution set here for our domain. You can write out in words. You can say all real numbers except 3. Some of us are used to the set builder notation. We can say that the domain is equal to the set, which is our brace, the set of all x such that x does not equal 3. And this is pretty much the standard way that you see the answers written on the ACT test or in an Algebra 2 trigonometry class. It is called set builder notation. The set of all x such that x does not equal 3.